So we are continuing on with BC topics. This is again something you did not cover last year. It's improper integrals. There's two different ways this can turn out. We're going to do one of the versions of it sort of today, and we'll do the other one next time. So we're going to do more improper integrals next time. One type of improper integral is when one or the other or both of the boundaries is infinity or negative infinity. Those are the ones we're going to do today. The ones we're going to do next time are even trickier because both of the boundaries will be numbers, but there will be a vertical asymptote somewhere in between, and you have to be aware of that. Like you have to have graph sense and understand where your vertical asymptotes are going to be. But that will be for next time. I'm letting you know all of the things. All right. Now we typically use A for the lower boundary and B for the upper boundary. At the end of the day, those are just letters of the alphabet, and if you want to pick something different, you can. I'm going to stay consistent with this though and use A for the lower one and B for the upper one, just because typically that's how you see it, okay? So if we are continuous from A to infinity, your integral, and again, derivative means slope, integral means area. We're going to get an area under a graph to infinity, which is kind of cool. It's cool. It's cool, guys. Cool. This is neat. You can get an actual answer even though it's infinite. It's cool. All right. Anyway, going from A onwards forever and ever and ever and ever and ever. I'm going to draw you a picture. If you're interested, you can draw one. If not, just look at mine. What's going to happen is something like this, where you have an asymptote. Here's A. This is, infinity. And the reason you can get an answer is because the graph has that leveling off feature. Do you get what I'm saying? We say it converges. Okay? If it works, it converges, you get an answer. If it doesn't, it diverges. I always think of that movie like Divergent. Think about it. Anyway, if you go from negative infinity up to B, it would look something like this. You're going to have that asymptote on the other side. Here's B, here's, negative infinity. And again, the reason you can get an actual numeric answer is because of that leveling off effect. If you go from negative infinity to positive infinity, like literally the whole thing, the only way you can get an answer is if both sides do what? Level off. So it's going to, do something like this, like you'll have that leveling off feature on both sides. But if you don't have an asymptote, it's not going to work. Diverges. They are four-step problems. You're going to set up your limit. Basically, you're just sort of rearranging the symbols on the paper. You're not really doing anything in that step. You're sort of just moving symbols around, okay? Antiderivative, that's the step that's calculus. Upper boundary minus lower boundary. And then lastly, you evaluate the limit. So quick pep talk. You have to write limit, blah, 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 at the front of every single step until you get to the end. Ms. Cole, what if I just want to remember? No, write it. It's part of the notation, and you guys are at a level where you need to know it, okay? So look at this first one. Do you see how the upper boundary is the one that's infinite? We typically use B for the upper boundary, so I'm going to use B for that. You could use any letter of the alphabet, really, but I'm going to stay consistent with how you usually see it. So it's going to be limit as B goes to infinity. And then we're going to make this integral from 1 to B. Everything else is going to stay the same. You're just going to copy it. And again, like I said, you're not really doing anything in that step. You're sort of just moving symbols around on the paper, okay? Actually, you could copy the rest of it, but I'm going to write it a different way. I just thought of this because I just looked at it. I want to write that as x to the what? Yeah, -2. Good job. dx. So I also made an executive decision there about how I wanted to write the problem, because I'm in charge, and so are you. We are in charge of the problem. All right, on your next step, you're going to write limit as B goes to infinity. You're going to write that at the beginning of every single step until you evaluate the limit. Now we're going to do the antiderivative. I'm going to do a little margin problem. You would add 1 to the power, so it's going to become less negative. That means it would be x to the -1. Perfect. Yeah, and you could put it over -1. That, again, comes down to personal preference. I'm going to write this, though, as -1 over x, good, such that 1 to b. After you do the antiderivative, you don't write the symbol anymore. Instead, you get such that, which means now we're going to evaluate it. Guess what we write first? Limit. You're going to write it 3 times. They're 4-step problems, and you evaluate the limit on the 4th step. So you should have limit written 3 times. You'll be okay. No problems. All right, so now we're going to do upper minus lower. Set it up blank. I'm a big fan of setting it up blank, and then you just go back and fill it in. So when you plug in B, You're basically rewriting it, except instead of -1 over x, it's -1 over b. That's kind of like, you're going to do a lot of recopying with this topic. It's sort of like that. All right, and if you plug in 1, you're going to just get -1. Now you evaluate the limit. All right. I'm going to use like a poor wording here. You're going to plug in infinity, which is not a thing. Like, plug in the largest number your brain can comprehend. Do you get what I'm saying? If you plug in like a trillion, 1 over a trillion is essentially, and that happens often with these problems, okay? That first part is 0, and then minus negative, so +1. And so the answer is 1, which represents what? Area under the graph. Let's try it again. Limit as b goes to infinity. Already? All right, integral from 1 to b. Again, we usually use b for the upper boundary and a for the lower boundary. You could use q if you want. I don't really care. I mean, just try and stick with a and b, though. I'm going to leave this one as 1 over x. 1 over x is a specific pattern. What is your antiderivative? Is ln. So, right, limit ln of x such that 1 to b. You have to like be really particular with your notation at this level, you know. You're going to write limit one more time. What step are we on now? We did the answer. Yeah, upper minus lower. So if you plug in b, it's just going to be ln of b. Like, again, this topic has a lot of recopying what you had before. Just accept that that's kind of the way it is and you'll be okay. Minus, now you do actually have to know what ln of 1 is. It is 0. Good job. Lastly, you evaluate the limit. You think about going to infinity, and I'm a graph person. I like thinking of a graph because it's visual. Your ln graph, if you want to draw it, you can. If not, that's cool. Your ln graph looks like this. It's that sideways swoop. What does this end of the graph do? It goes up forever and ever and ever. So this first part goes to infinity, and then you have -0. Is that a number? No. So we say it diverges. And that's your answer. It's kind of like your version of no solution, but we say diverges, and then that's the answer. No, because infinity is not a value of area. I could not say I have infinity dollars, or I am infinity inches tall, or there's infinity square feet in this room. You know, it's not a value of something. Converges means it comes to a certain value. Levels off at a certain value. Diverges means it does not have that behavior. Okay? Okay. Now, I'm also a big fan of showing you something ahead of time before we get to it, like almost tricking you into learning it before we get there. So we're actually going to cover one of our infinite series right now, which is called a P series. It's only going to work for 1 to infinity, though. So if this is any other number, this is not going to work. And it's going to look like this: 1 over x to the power p, p for power. Again, it only works for what to what? 1 to infinity. Okay, but you do see that a lot. If p is greater than 1, it's going to work, and your answer is 1 over p minus 1. So you can skip all the work and just get your answer. What? If p is less than or equal to 1, then it diverges. So for example, in question 2, what is, it's like a what? Oh, well, sort of. Well, there's just two different options. I wouldn't think of that as a piecewise function. I would think of that more as like a flow chart. Do you ever see a flow chart? Like if this is your answer, go here, and if that's your answer, go here. It's an if else, yes. Thank you. It's an if else. All right, so look at this one. What was p in this one? It's kind of not written. 1. That means diverges. What was p in this one? 2. If you have 1 over 2 minus 1, you get 1, which is the answer. So you can skip all the work. So we'll just try a couple like that. Do you see how it's 1 to infinity? What's p? 1/2. That's less than 1, so diverges. so that I can explain to you why it works. Also, when we flip over the paper, you notice how it's not 1 to infinity, and you have to actually know how to work it out. I do know what I'm doing, okay? Go ahead. Square root power is a half. What would cube root power be? 1/3. A fourth root would be a fourth, and then we don't have names for them.
Is that thing valid? If I was given like question 3, I'd put that word.
Yes. So when we get to we'll talk about this a ton more when we get to like unit 10. Okay. But I'll be like, hey, look, I already taught it to you. You say what P equals, and then usually they would want you to include this, like show that it's smaller than 1, but that's your justification. You say P equals this. Here, I'll show you on this one. P is what for this one? 5, which is greater than 1. So our answer, we are going to get an answer, 1 over 5 minus 1, which is 1/4. Yeah, that's your justification. You're saying P equals this, and that is either bigger or smaller than 1.
Can we write P equals 5 is greater than 1?
Yeah. Mm-hmm. 1 over 5 minus 1 yes, you don't have to evaluate. Cool. See, I taught part of that unit to you already. That's one of my favorite units too. I love the infinite series unit. I'm probably like the only one, but all right. We're going to do limit as b goes to infinity. And then integral 4 to b. And I don't want to write 1 over x cubed. I'm going to write x to the -3 dx. Do you want to try this one? And then we'll come back together? Because I feel like I did enough of them now that you could maybe try one. Or do you want me to just walk you through it? Let me try. Okay.
That's what I got. I'm not done yet. I feel that. I don't even know if I did the anti-seven.
All right, so I wrote out the step with the antiderivative. Now we're going to do upper minus lower. So when you plug in b, it's just going to look the exact same thing. All right, plugging in 4 squared. 16, double that, 32. So -1/32. Now, if you quote unquote plug in infinity, that's not really a thing, but you're plugging in like the largest number possible. Yeah, it's like 0. 1 over a gazillion. So this is 0 plus 1 over 32. And so your answer is 1 over 32. But hold on, because there's a question. Go ahead. Or were you just happy you got it right? Every right answer in calculus is a celebration. So yes. But was there a question? They're not going to like that. That's technically that's not correct notation. I like to believe, though, that if you got down to the answer of 1 over 32, they would let that slide. But did you guys all hear that? That's a good question. Don't write this. Like, that's a no-no. Do you get what I'm saying? Please don't do that, because infinity is not a number. Yes, that's a really good way of saying it. Okay, yeah, don't do that. They will likely not give you credit for that, because infinity is not a number. So if you start doing things with it like you're treating it like a number, then that's not good. All right. If you guys can hold it together through one more, then I'll give you a brain break, okay? All right, so we're going to do limit b goes to infinity, integral -1 to b. Again, this first step, let's quiet it back down. This first step, you're really just rearranging symbols, okay? Now, I'm going to write this inside part as -4 times that stuff to the -3rd. Good. There's going to be a u nicely noticed. There's going to be a u substitution, but we're not going to actually write it all out. Do you see how there's a 3 there? In front, we're just going to slap a 1/3. Okay. If it was a 5 out front, we would put 1 over 5. Okay. Just if it's a really simple thing, you don't have to write it all out. I'm going to get you through it though. I'm glad you guys noticed that, but everybody just chill. Just chill. Okay. We're going to write limit. You have to write that 3 times. I'm going to do this as a side problem. I'm going to take the -3 and add 1. So it will become -2. In front of that, I need a -1/2. And I'm going to just pause for a second to make sure everybody's with me. Are we all still? Okay. And then in front of that, you're going to need that 1/3 that we just talked about. To cancel out the 3, you need that 1/3. And then what else do you need because it's sort of just there? Yeah, the -4 that's in the problem. Okay, hold on. Go ahead.
Why is the, why is the 4 not positive? Because you're bringing it up.
It just is negative in the problem. Like it's just a -4.
Oh, wait. Never mind.
But if I understand what you're saying, and if you chose to write it that way, we should end up in the same place at the end. Oh, okay, gotcha. Can I talk everybody just through it again? Everybody just kind of freaked out there. So we raised the power to -2. That means in front you need a -1/2. Why'd we put a 1/3? Because this 3 here. If it was a 7, we would put a 1/7. Yeah, it's like a chain rule. And then why is the -4 there? Well, I don't have a good explanation for that. It's kind of just there. All right. So let's sort through this. First of all, the negatives are going to cancel. Half of 4 would be 2, and then thirds. Okay, so we got 2/3 out of all of that. And then you have this 3x plus 4 squared. Why am I putting that on the denominator? Because it was negative. Okay. Again, that is the hardest step. Step 2 is the hardest step because that's the calculus. That's the meat of the whole thing. Now we could just kind of fly through. What step are we on now? Right, the third step. But what does that mean we're going to do? Yeah, upper minus lower. Plug and chug. After that, it's kind of smooth sailing. Okay. For plugging in B, you just copy the whole thing, but plug in B. Again, this topic is, I keep saying that. You're probably sick of hearing me saying it. This topic is kind of like that. You're just going to recopy stuff. And then plugging in -1. Oh, geez. What would that be? -3 plus 4. 1 squared is 1 times 2/3 would just be 2/3. And then here's where you get your answer. If you quote unquote plug in infinity, or like the largest number you possibly could, 2 over a gazillion, which would be 0, minus 2/3, which means your area is under below sea level, under the x-axis. Okay. All right. So do you notice how on this one, the infinite boundary is the lower one? So typically we use a for that. So it's going to be limit as a goes to -infinity, and then we're going to have integral from a to 0. I only put one of these on here because typically it's the upper boundary that they'll make infinity. You don't see this as often, but it's like true. Okay. What'd you say? Okay. I mean, it's not any different really. And hey, Miss Cole, could I still use B? Yeah, use whatever letter of the alphabet you want. I'm just trying to be consistent with what like the powers that be have made it. All right. So we're going to write limit again. And then we're going to do an antiderivative. I'm going to cover up the -6 for a second because it's kind of just there. Just like that -4 in the other problem, sort of just hanging out. Okay. What is your antiderivative for e to the 4x? E to the 4x, but in front of it, you would need a 1/4. Okay, so it's going to look like this. -6 times 1/4 e to the 4x, such that, and we're going to evaluate from a to 0. Yes, and in fact, I'm going to reduce it in the next step. -6/4 would be -3/2. I just wrote it that way so everyone could see what happened. If I skip too many steps, then I lose everybody. It's a u substitution. But instead of writing out u equals 4x, du equals 4 dx, 1/4 d. Do you get what I'm saying? I'm like, since it's just a 4, slap a 1/4 in there, you're good to go. Yes. That's it. Okay. So this is, lost my train of thought. We're doing upper minus lower. So if we plug in 0, e to the 0 power is not, please no one say 0. It's 1 times -3/2 would be -3/2. All right. And then if you plug in a, it's going to be -3/2 e to the 4a. Just recopying it with an a in there. Now we evaluate the limit. Little tricky because it's not positive infinity. It is negative infinity. So just hold on and don't talk over me so I can explain it to everybody. First part is -3/2. These negatives are going to cancel, but it's not really going to matter much because if this is negative infinity, or imagine like a negatively huge number, that negative is going to reciprocate it. So you're going to end up with that same situation where you have like 3 over the biggest number you can possibly think of. So it's going to go to 0 because it was a negative infinity. It reciprocated it. And so your answer is -3/2, which means that your area is below sea level. And again, please do not write sea level on your AP exam, because I had somebody write that on a test for me once and I was like, oh goodness, please, I need to fix this. Do not write that on the AP exam. You need to say is negative, okay? Or below the x-axis. Let's go through number 8. All right, it's going to be limit as b goes to infinity, integral 1 to b, and then basically just copy the rest of that. But I love how that worked out, that the question you asked is like the next example that I'm going to do, because I try to throw one of everything on here. All right, now we're going to write limit. B goes to infinity. Antiderivative. Now hold on. The 5 is kind of just there. I'm going to cover it up. Antiderivative of e to the 3/4 x is going to be e to the 3/4 x, but in front you would put perfect, and then times 5 is like, hey, wait for me, you know, like I'm here too, just sort of there, such that 1 to b. All right, so, and I hear you guys talking through it, but just wait for me. This is going to be upper minus lower. That is 5 over 1. If it helps you to put that over 1, you can do that. Personal preference. 5 times 4 is 20. So it would be 20/3 e to the 3/4 b. And then if you plug in 1, you're going to get just 20/3 e to the 3/4, whatever that is. That's a number though, right? Because e is how much? 2.7. If you know it's a number, I'm happy. If you know it's 2.7, I'm even happier. If you know it's, does anyone know it further? It's 718, but yeah, cool. All right, now if you plug in the most gigantic number you can think of, you end up with e to a gazillion, which is going to be like a lot. I like that, a lot. It's going to go upwards forever. The other thing you could do is think of a graph. That's what I like to think of. E is a swoop, goes like this. Or do you ever hear of blah, blah, blah is growing exponentially? They mean really fast. Like, you know. And then minus whatever this is. I don't feel like writing it, but yes, diverges. We're going to do one more. I'm not going to be your favorite person on this one. That's okay. I wanted to at least do one that was negative infinity to positive infinity. You're going to write the same thing over and over and over again for most of this. Life is like that sometimes, okay? You've been warned. I read you the fine print. Go ahead. The one we're about to do? No, it has to be x to a power. This is not exponential. It has to be a polynomial. That's a really good question. It has to be like x to the 3rd, x to the 4th, x to the 5th. Yeah, that's not going to work. Weirdly, 3/4 was smaller than 1, but if instead of 3/4, say it was 12, still would have diverged. So that's, you know, that's not going to work. All right. So limit as a goes to what? Negative infinity. Good. Integral a to something. We have to split this somewhere. You can't go from negative infinity to positive infinity all in one fell swoop. Thank you. We're going to go from negative infinity to 0, and then we're going to go from 0 to infinity. Okay, so we're going to go a to 0 of this thing, dx, plus, and then we're going to do limit b goes to infinity. What would the boundaries on that one? Well, 0 to b, yes. Of that exact same thing. So again, as a heads up, you're sort of doing 2 problems and you're going to write the same thing over and over and over again. You've been warned. I like to believe they wouldn't give you one that was negative infinity to positive infinity, but it's technically fair game, so I'm going to show it to you. Yeah, I kind of don't either. I'm on your side. I'm still going to show it to you. All right. So we're going to write limit. Now here's where we're going to do the antiderivative. I feel like if I wait you out, someone will come up with it. It's one of the tools that's in your toolbox. Wait, everyone's talking at once and now I don't know.
Okay. So it's 1/2 times what we already have. That sounds like 10.
Good. Why is it arctangent? There's not a square root. A, we got there. A is what? A number. Good. Specifically 4. U is x, so du is dx. All right. It is 1/4 arctangent of x over 4. I'm going to just go ahead and write the rest of this. If you only kind of want to do half of it and then like finish the rest at the end, that's kind of fair. I'm going to write all of it because I'm recording this. Yes. So if you aren't sure, probably arctangent. I love when you guys do that. You know what that reminds me of? Does anyone play Minecraft? Do you know like the villagers? Anyway, I was thinking about the villagers. All right. Limit a goes to negative infinity. That limit was horrible. Let me try and rewrite that. All right. So this is going to be upper minus lower. I'm going to real quick draw the tangent graph off to the side so that you guys can see this. Does anyone remember what tangent looks like, sort of? I'll be impressed. But yes, they look like, what did you say? So it goes through the origin 0, 0. It has a vertical asymptote at pi over 2 and negative pi over 2, and it looks like this. And then you would have more squiggly things. But that's the only one we're going to need, so I'm not going to draw any more of them. Does this ring any bells at all? I mean, see, this is where this happens is like, I don't have time to fill in all the gaps. That's what tangent looks like. Cool? Yeah. Do you know what sine and cosine look like? Yeah. Like what? Wait. Okay. All right. So when we do upper, we're going to plug in 0. Do you see how this is the point 0, 0? So if you plug in 0, you're going to get 0. Cool. You came with me on that. And then you're going to recopy the thing, but put A. I didn't leave enough room. So I have to erase. See, this was a good idea for me to write with pencil today because I knew I was going to have to erase something at some point. All right, plus, and then we've got this totally separate problem over here. We're going to do upper minus lower. And so again, you're going to just recopy the thing with B in there. And then 0. The thing I do also say as a pep talk about this is like, if your parents ask you how your day was, like all you really need to do is show them this, and they're probably not going to ask you any more questions.
My dad's gonna be like,
oh, you might have a different situation there.
Oh wait, I'm not going home today. Let's go.
Okay, last thing we're going to do is evaluate the limit. We're almost home. Okay, do you see how this says negative infinity? Can you just look at the picture? Towards negative infinity is at what value? Cool, you came with me on that. So it's going to be negative 1/4 times negative pi over 2. You can keep the 0 in there as well if you want. Because it's arc, we're looking at y, and then we put our answer as x. Because it's arc tangent.
So that's kind of the entire graph there.
Well, and there's more to this graph, but we don't need it, so I didn't draw it. There's an infinite number of those squiggly things. All right. Plus, all right, let me finish this up. Infinity. Can you all look at this? Going to infinity happens at pi over 2. Okay, so this is going to be 1/4 times pi over 2, and then you could keep the minus 0 in there if you felt like it. But we're so close that like this is like getting to the last 10 feet of a marathon and then stopping. Let's finish it off, okay? These negatives are going to cancel. You get pi over 8. Good. Plus, and then this would also be pi over 8. Perfect.
I'm not gonna lie.